All right. Good afternoon, everyone. Good day. Paul Craddock, Senior Specialist Solutions Architect here at AWS, and welcome to our next installment of the VMware Cloud on AWS Deep Dive series. Today, we're going to focus on advanced networking specifically with VMware Cloud on AWS, as well as security VPCs and deep dive AWS network firewall. So we've got a lot of great content here. So we have a couple of new speakers to the series. I'd love to welcome Joseph Brown and Alex. Actually, Joseph, Alex, go ahead and, if you don't mind, just introduce yourselves real quick to everyone, and then we're going to go play a game.
All right. Hey, I'm Joseph Brown. I'm also a senior solutions specialist here at AWS, focusing on VMware Cloud on AWS. Alex?
Hey everybody, my name is Alex Pilnev. I'm a VMware Cloud on AWS specialist. Thank you for having us.
Custom here, we got a lot of great content around network deep dive.
Let's take a look what we prepared for you today. So we'll start with our lab environment and define goals, what we were trying to accomplish with this setup. Then we're going to talk about microsegmentation, how you can organize granular protection of your resources using NSXT distributed firewall. So we're going through implementation and show you how it needs to be done. Then we're going to talk about security VPC, how you can implement traffic inspection for your VMC on AWS workloads and also expand those capabilities to native AWS resources you have. At the end, we're going to talk about NSX-Edge failover, how exactly those scenarios handle if you have a hardware malfunction and when you have NSX-Edge restarted on a different ESXi host. And at the end, we have a quiz, so with the prizes. So pay attention and let's start. So I want to start with our lab environment and define goals we have or challenges you might have during implementing your cloud journey. So here is a design we have in our lab. So let's talk about it. Why it's built in such a way. So first of all, let's say you start your journey to the cloud. You're starting to moving your workloads. You may start using native AWS tools, or you have a VMware Cloud on AWS. So migration of workloads, it's relatively easy and you are familiar with this. Now we have requirements from our security personnel. We need to implement traffic inspection and we need to implement protection of our workloads to limit communication with outside world or maybe implement intrusion detection and intrusion prevention system for your workloads. You're familiar with NSXT, which is a key component to organize protection of network resources inside SDDC. So, and it could be used in such manner to organize protection of your workloads. However, it's a limitation that you cannot use it to protect native AWS traffic. So it's a capable and powerful tool to do traffic protection inside SDDC, but it's not expanding toward native AWS services. So for this particular purpose, we are going to show you design called security VPC design, which allows you to forward traffic from SDDC to a special managed service. And here we're going to use AWS Network Firewall for the purpose of deep traffic inspection. AWS Network Firewall allows you to organize perimeter protection of your resources. So it's inspecting not only what's getting in, but also what is getting out. And here we're going to show you how this could be leveraged to organize protection, not only your workloads inside SDDC, but also how it could be integrated with native AWS services. So you are getting single pane of glass to manage security and traffic inspection for whatever resources you have, VPC and native AWS environment or resources running in VMware Cloud on AWS. So to make it work, one of the things we need to do, we would like to forward all traffic from our SDDC all the way to our AWS Network Firewall inspection. So to be able to do this, we are using VMware Transit Connect, and our SDDC configured with a default route to send traffic to Transit Connect and then going all the way for traffic inspection. So we start our demo with a simple task. Let's say we have a segments and we would like to do protection of those segments inside SDDC. So this approach called microsegmentation and NSX distributed firewall. So what is the task here? As you know, inside SDDC Cloud Gateway, taking care of protection networking and network communication between network segments where you're running your workloads. So when you're creating different segments, Cloud Gateway by default restrict those cross-segment communication. So for example, here we have a pink segment with TCL web servers, and we have a blue segment with GFW workloads. So when you provision new segment, VMs in a pink segment cannot talk to blue segment unless you define firewall rules inside Cloud Gateway to allow this traffic. On the other hand, communication inside segments unrestricted. So for example, in our blue segment, all VMs are capable to talk to each other. So there is no restriction, and it works in the same way as a distributed port group inside our vSphere. Now, how you can organize protection, how you can prevent those VMs talking to each other. Now, because they're inside the segment, traffic is not going to Cloud Gateway. So there must be a way how we can prevent those communication. So, and for example, stop a spread of infection or attack from one vulnerable web server. So how we can protect the rest of our workloads inside that particular segment. To do this, we're going to use a feature called distributed firewall. This allows you to establish firewall rules literally on a virtual machine network interface. So, and let's take a look how it works. So there are two steps you need to take to activate distributed firewall. First of all, you need to define groups of protected resources. So in this particular case, what we are trying to accomplish, we have a management VM, which our administrator used to reach our web servers, and we have web servers in exact same segment. So we would want to allow management VM talk to web servers through SSH and ICMP. We want to web servers have a communication through HTTP and HTTPS, and we want to drop all other traffic. So to do this, we define groups of protected resources. So here we have a group for management VM, and we have a group for our web servers. The second part would be to create distributed firewall rules to restrict those communication. So the way how it works from top to down. So first we define our permit rules, and at the bottom we define our drop rule. So as a source, to allow SSH communication to our web servers, we select our management group, and as a destination, we're going to have our web servers. Now let's take a look how it works. So here we have NSX Manager interface. And first we're going to create new segment. Those would be a segment where we're going to place later our web servers. All right, here we defined our segment. Now our administrator provisioned our web servers in this particular segment. The second step would be to define groups of protected resources. And here we define membership. For the sake of lab, we are using IP addresses to define what exactly going to be a member of this group. But here are not limited only by IP address. Now we're going to define group for our web servers. In this scenario, we have two web servers. So again, for simplicity, we're just going to define IP addresses for those web servers. All right, now we have groups. Next step would be to define firewall policy. And we go into a security and we are going to a distributed firewall. That's where you're going to apply your distributed firewall policies. I would recommend when you create your own policies, always use the meaningful names. So it would be self-documented configuration of your environment, and it would be easier to identify what you're doing. So here we have a policy, and now we're going to define the rules. So this one is going to allow communication from our management station through SSH to our web servers. So source is going to be our management group, which we created on a previous step. And the destination is going to be our web group. Now we need to define services. So that means protocols, what we're going to use. So you can use a search to quickly identify or find it. So in this case, we have SSH. And here is a rule, allow traffic. Now we need to create two more rules. And again, in the destination, we select our group of web servers. So to be specific, where those rules are going to be applicable. And we need to add HTTP and HTTPS as protected ways of communications. And the last rule, where we're going to drop all other traffic which sent to web servers. So that rule is going to prevent communication inside the segment between those VMs. Very important thing, rules work from top to bottom. So that's important. What is the order of rules you defined in your policy? So now we have this activated. So let's take a look how it works when distributed firewall is not in use. So we're going to disable those policy and publish rules with no restriction. So we have a management box, and you can see we can reach both of our web servers just fine. And again, without distributed firewall, nothing prevent two web servers to talk to each other. All right, now let's take a look how situation is going to be different when we activate our distributed firewall policy. So we're switch it to active and we're going to publish this rule. Unless you push publish, rule is not going to be applied on NSX side. Now, because we allowed all web traffic, we're still capable to reach to open web page from our servers. However, that's the only traffic we allowed, so we can't SSH or ping those web servers from our jump box. Now you can see that web servers cannot ping each other and cannot SSH to each other because, again, we blocked those transmission using distributed firewall. However, because we have a rule for our management server, we still can reach web servers, web pages on our web servers and SSH to them. So this is a good example how you can use distributed firewall for the purpose of restricting communication inside the segment. So it could be used to limit spread of malware. It could be used to prevent distribution of attack inside the segment, or it could be used for the purpose of isolating environments and, for example, have test and dev environment exactly in the same segment, but with restricted access. Now I want to pass microphone to Joseph and talk about security VPC implementation, how we can do traffic inspection for your workloads.
Thanks, Alex. And thanks for highlighting some good use cases for the distributed firewall as well. Now we're going to shift our attention to the AWS side. Here we're working on the left side of the lab diagram we showed you earlier. We're going to set up a configuration with security VPC to force all the traffic through the firewall using the firewall endpoint. You see we've got specific subnets assigned here. We have one dedicated to the firewall, one dedicated to the NAT gateway. We have a protected subnet inside of the security VPC, and we have one assigned to the transit gateway. All of these are going to have associated route tables, and it's through those route tables that we're going to be able to control this traffic. Let's have a look at how this is done. There's This step here is what assigns this route table to the internet gateway. By default, it has just a local route, which we're going to leave here for the moment. And we previously configured the firewall route tables and some of the others. We're just going to quickly review what's in those. Again, only associated with the one firewall subnet here. And the default route, as you can see, is pointing to the internet gateway. And in this route table, we've assigned the default route to point to the firewall endpoint. Now we assigned a specific subnet and a route table to the transit gateway in order to be able to control this traffic. If you don't do this and you only have a default assigned to this, any change you make to support any instances you deploy inside of this will impact your network flows here to and from the transit gateway. You'll see here that it's because we're using private IP space inside of the SDDC. And we're also advertising an additional SDDC, the one at the 10.202, as well as the subnets or the networks assigned to the SDDC. Now this step is where we force the traffic to use the firewall. Currently, you could theoretically get around the firewall and pass traffic to and from the network gateway as long as it's on that local subnet, the 10.250. But once we set this next route, that won't be possible any longer. So these return routes, all pointing at the firewall, force all ingress traffic from the internet gateway to follow these paths. Let's see how this all works now. So here we're working with the web server that's in the connected VPC. This traffic is flowing through the ENI directly to and from the SDDC. So this will not flow through the firewall in this configuration. So this host that we're working from now on the left-hand side is the one in the protected subnet. Now this host is on the actual network with the firewall. Interesting thing about this one that you have to keep in mind is this cannot be protected by the firewall, and the firewall cannot protect against it. So it's important that you do not put hosts on this network. We just wanted to demonstrate that it can reach all of these, and it doesn't have anything restricting its flow. So we're going to go back to Alex, and he's going to just talk through some of the firewall capabilities.
Thank you, Joseph. All right, let's take a look. What is the heart of security VPC? So for this, to keep in mind, AWS Network Firewall is a perimeter firewall. Its purpose to inspect traffic in and out of your VPC. In this particular design with the security VPC, we are forcing all traffic in and out through our network firewall for the inspection. Because network firewall is a managed service, so you don't need to worry about scalability of this. So those things are taken care by AWS. Where you can find network firewall. So it is a part of your VPC. In this particular case, we have our security VPC, and you can find network firewall settings in a network firewall section of your management console. So how it works, you need to define firewall policy. So network firewall supports stateless policies and stateful policies. So stateless, and we're using stateless for this lab, think of it as a classic layer 3 firewall. All it's care about is IP addresses, in and out. If you're looking to have a more deep inspection of your traffic, and that's exactly the purpose of this security VPC, we can activate stateful inspection. So stateful rule group is a group that uses Suricata-compatible intrusion prevention system specification. So those are predefined, managed by AWS rules you can start consuming right after you configure your environment and apply those rules to inspect your traffic. So we have a pretty good documentation explaining how those specific rule could be used. So you can see AWS Network Firewall is capable for a broad selection of different traffic and inspection you might need. So you can configure behavior of the thing as a drop any suspicious connection, or you can send alerts to your security team and make them aware that there is something bad is happening. So, however, as I said, you can start consuming already pre-configured services, or you can build your own rules. And they just need to be in Suricata specification. And again, we have a document at the end of this webinar. We're going to post a link where you can take a look and take advantage of this system. So in this particular case, with a stateful rule, we can have up to layer 7 traffic inspection and have intrusion detection, intrusion prevention system. Now, you probably heard that besides network firewalls, there are multiple other tools in AWS portfolio to organize protection of your workloads. And one of them precisely built for protecting web resources is Web Application Firewall. So it could be used again to organize protection of workloads inside your VMware environment or inside native AWS thing. So key moment to organize this protection, all you need to do just to forward traffic towards the endpoint where this Web Application Firewall would be applicable. Web Application Firewall purpose is inspection of HTTP traffic. So it's giving you protection for an inspection of HTTP body and HTTP request, cross-site, and SQL injection. So it could be like a precise tool to organize protection for your web traffic or internet gateway endpoints. Oh, I'm sorry, API gateways. Which out of those multiple solutions is right for me? Well, it depends on what exactly you are looking to accomplish. And here's just a couple things to consider when you are applying security configuration for your environment. So you can see with AWS Network Firewall, we have inspection of all kinds of traffic. So we are not limited only to the web. So if you have a requirement to have a broad inspection of different types of traffic, that would be your answer. If you are looking to have just a web inspection, you can look at web application firewall. Those solutions are not mutually exclusive, so you can combine them for different types of workloads and they can coexist in your environment. So all you need to do is just proper configure your routing tables and the way how traffic flows from inside and from outside and between your VPC environments.
Hey, Alex, thanks for that. Keep in mind that as we do this, the whole goal is security in depth. So you could layer in an application firewall, the network firewall, this with your security groups, leveraging the capabilities of the firewall of NSXT. And not only that, we did highlight today the AWS network firewall, but you could substitute in place of that any of the third-party firewall offerings available through the marketplace. So you have many different tools that you can solve this with. A couple key points, even with those, keep in mind you do need the ingress route table on the internet gateway, and you should configure a dedicated subnet for your transit gateway attachments to give you more control over the routing with those. Thanks, Alex.
Thank you, Joseph. And the last section for today, we're going to take a look how NSX Edge support failover and how a routing table is going to handle for you in case of a hardware malfunction. So let's take a look. So here is a diagram how connectivity from VMC organized with AWS resources. So we have NSX Edge running on a particular ESXi host, and network interface of that particular host is associated with our connected VPC. So our communication in and out from SDDC to AWS going exactly through this network interface. There is a thing called a traffic list, and we'll show it in a demo. That's a list of networks living inside SDDC, and this traffic list advertised automatically inside our VPC environment. So whenever we create a new segment, main routing table is populated with this traffic list. Now, what is how situation is going to be handled if we have an NSX failure or we have a physical host failure? So NSX is working as a pair. So you have active and standby edges. So when active edge failed or physical host failed or appliance itself, your traffic is going to be rerouted to a standby device, which is now be promoted as active. And because it's running on a different ESXi host, your traffic is going to be sent through a different network interface. So when this part is happening, VMC sent update to AWS routing table, and now we can see that route from the VPC side going to use this particular network interface again to establish communication with SDDC workloads. So let's take a look on this part. So for simplicity of the demo, we're going to use connected SDDC because it's much easier to identify those components we just talked about. So here in a connected SDDC, we have a thing called a prefix list. So this is what we got from our VMC environment. In this prefix list, we have a list of our segments. So our 16.1, 16.0 segments, that's where we have our web servers. And at the bottom, we have SDDC management network. So those networks are now let's take a look on our routing table. And again, we're going to look at our connected SDDC routing table. So you can notice that we have this prefix list and target ENI. So this is a network interface on ESXi side. Now, if we look at network interfaces inside our connected VPC, you can notice there are multiple of them. Those are getting pre-provisioned during your SDDC deployment, so those are part of it, and which in use. So this one, because that's our host in our lab. When you adding new host to your management cluster, to a first cluster in SDDC, so this pre-provisioned elastic network interface is going to be picked up, and in case when failovers happen, they be rotated automatically. So here we can see we have two network interfaces available for us right now. 3619 is what the network interface our VPC used to send traffic to our SDDC workloads. So, and that's it for the demo part. So please take a look. Here we prepared some resources. I encourage you to take a look and see how they could be applicable for business cases. So VPC ingress routing, and its broad capability for traffic inspection, intrusion prevention, and detection. Now, time for questions.
Yeah, thanks, thanks, Joseph and Alex. We do have a couple of questions in chat here, and we'll give everyone a chance to scan this while we answer some of these questions. So first of all, one question, just a logistics question. Is the slide deck available for access somewhere? Unfortunately, not yet. Will these recordings be emailed? They won't be. We're actually working internally to get, we've got a bunch of the deep dive series that we're working to get published on YouTube. So hopefully we'll have those publicly available soon. Apologize that I don't have a date for those. So I just wanted to address those. Let's see. So a question now back from the actual technology here. How important is it to translate external firewall? Sorry. This question more is there a way to import external firewall rules on-prem for use within the AWS network firewall or web application firewall? Is that possible today? Is that something that we know about?
And it's not something we have personally done. However, I did post a link that describes how this is done with some of the partner integrations. But another advantage of the firewall is that if your device can export them into Suricata format, or if you're using Suricata or Snort or something like that, and can put them in the compatible format, you can copy and paste those into the firewall and create your own policy set that those can be used to then apply to your traffic. So, there is capability of doing that. It's not necessarily a click and done, though there are some integrations that may make that possible. Additionally, if you don't want to leave your current vendor, if they're available in the marketplace, you can just simply use that and connect that up to whatever management, if you're using centralized management, and handle it that way, or again, export them and import them into the one that you deploy on EC2 inside of the security VPC.
Awesome. Thanks. Were there I didn't see any other questions in the chat. If there are, please go ahead and post them and we will answer those live. Another just a thing to comment about before we transition to games is egress costs. So this is something that we talk to customers a lot about. This is a common concern of, hey, what is the egress cost for solutions like this? And that is a really challenging question to answer. So something to consider. There is egress cost to leave our VPCs, to leave our availability zones, and so there are ways to potentially architect around some of that, right? Using like the connected VPC for different things, but in a security VPC design that doesn't apply as much. So what I would encourage anyone to do is to review requirements. You as the customer have requirements, and so if you truly need to inspect every bit that in and out of your SDDC, and then absolutely the design we just showed you is something you're really going to want to take a look at and deep dive. But if there are trusted security zones that on-prem these are trusted, we don't inspect between these trusted zones, then it might be a better idea to get a little targeted and not egress all of those various different subnets out of our availability zones, out of our various different VPCs. It's nice to just try to inspect the things that are required there. So, but just keep that in mind. There are some egress fees. They're generally fairly nominal, but again, it's just something that we all need to consider.
And Paul, on that point, one of the
please.
things that helps with that is implementing, and this is not limited to security VPC, you can deploy a dedicated subnet and a dedicated route table to any connection you make for transit gateway. And in doing so, if you want to keep that traffic flowing alternative paths so you're not passing across the transit gateway, you're able to do that.
Yeah, great point. Let's see, there's a question from Jim. Is it possible to implement in a Linux-based system without other AWS features? Sorry, Jim, I'm not 100% sure I follow the question completely. I mean, from a Linux point of view, yes, we can inspect traffic. If you're talking though about like our AWS network firewall and WAF, we do not. It's not possible. If maybe this is your question, so if it's not, please type and let me know. It's not possible to just host these yourself and say your own EC2 instance or containers. These are just features and solutions you can turn on within your AWS account and leverage. So it's not necessarily possible to just extract those and host those yourself. I don't know if that's exactly what you're asking, but if it was.
And on that though, if he's asking if he can roll your own, like maybe a pfSense or some other open source firewall, that is possible. You can deploy
yes.
the appropriate Linux distribution from to your EC2 instance, or with your EC2 instance, I should say, and then implement that just as you would any other package. And just as you do with a third-party firewall, you follow those instructions, create the interfaces you need, put them in the appropriate route tables to set up your security zone.